Hello, my name's Harv Sorn, Technical Specialist for Fusion 360 here at Autodesk. And today we're going to go ahead and take a look at the future of making things. If we start by looking at our customer's current process, we'll see that it is quite linear in nature. They start off on a concept phase, maybe creating some hand sketches for the design that they want to go ahead and generate, move into the process of generating some more detailed design work, generating 2D drawings and bits and pieces like that to manufacture their products. Move into a production phase, into a traditional sales phase where they need to go through a period of selling to see what the markets are doing, and then finally into a operate and retire phase. Now we term this a traditional product lifecycle, and it only has a fixed product value. Now during the sales and operation and retire phase, companies are usually thinking about the next design that needs to come to market. Now, here at Autodesk, we're looking at the future of making things. And our understanding of the future of making things is during the concept phase, we personalize that engagement with the customer, giving them a bit more of a customized product. During the design phase, we collaborate with virtual teams across different time zones potentially. During the production phase, we take advantage of all the advancements in manufacturing, such as additive manufacturing with 3D printing and metal additive, as well as the advancements in CNC technology. During the sales phase, we have a more engaged customer experience, giving the customer a bit more of a personalized engagement. And then finally, we can go ahead and connect all of our products to IoT and Industry 4.0 to then gather a bit more information from the product while it's in use. And we term this product as a service, and it has an increased lifetime value. And it gives us the ability to have a more agile product development, taking information from when the product's out in use and informing that for the next generation of product that we need to generate. And we term that the future of making things here at Autodesk. And we go ahead and sit that on what we call the product innovation platform. At the center of this platform is Fusion itself. We have our design phases, so we can quickly and easily start to generate that design that we need from concept all the way through to production. We go into our make phases and we can go ahead and harness all the technology for CNC machining as well as 3D printing, and finally into the use phase to then go ahead and connect our product and generate a real nice complete solution from design, make and use. Now, pushing the boundaries of this, we have other technology that sits within Fusion as well, something called generative design. So from here, we can start to develop the design, optimizing cost, material usage, still maintaining strength, and still keeping that weight low, giving us a better product as we go. During the make phases, we go into industrial additive. We have the ability to integrate CNC as well as additive manufacture, giving us the ability to potentially 3D print something and also do some final machining on it. And then during the use phase, we have a product that we can then go ahead and connect into the ecosystem to then have Industry 4.0 and feed us back that information into the design, letting us make more informed decisions earlier within the actual design process. And this is what we term the product innovation platform. It's a single integrated product development platform to take us our designs from concept through to engineering and out to production. So we can then go ahead and look at the form, generating the model within Fusion, look at the function to test to make sure that everything fits together as it should do, out to fabricate, whether these are traditional CNC machining methods or even the additive environment, and then manage all of that data within our product development platform. So today we're going to go ahead and look at something called Fusion Canine, which is a robotic dog. We're going to go ahead and design a part of Fusion Canine itself, and we're going to take you through the product innovation platform. We'll look at the design phase, we'll move into some communication, some virtual testing, bit of visualization, and then finally the create phase itself. So let's go ahead and take a look at the design aspect of Fusion. We're going to go ahead and design that chest that you see on the right hand side of the screen, and we're going to go ahead and look at some parametric modeling as well as some complex surface and ergonomic shape creation within Fusion 360. And we're going to see the integration of the platform itself so that we can take a design really quickly from just a standard product all the way through to something a little bit ergonomic. So let's jump into Fusion. Now, Fusion itself is quite a clean platform. As you can see, I've got Fusion Canine on screen just here. We have a nice toolbar along the top that's very neat. We have our tree down the left-hand side of the screen that gives us all of our parts, and we have the ability to go ahead and see all of the projects and data we are working on the left-hand side of the screen. So we can access any part of that environment and put any folders and organize that data as we need to. So let's go ahead and hide just the chest cover of Fusion Canine just here so that we can see what we're actually going to go ahead and design. So we need that chest section to fit into the actual part, into Fusion Canine just here, and we can see the parts that need to go ahead and merge into that body. So we can quickly and easily start to develop that design within Fusion. So let's go ahead and jump into a new design, and let's go ahead and start sketching. Now the first thing that we want to go ahead and do here is just use your standard lines, arcs, circle tools to generate a real quick, real basic profile of what we're trying to create. Now this is just going to be a cylinder, so we're going to go ahead and draw a few lines out. We're going to go ahead and then revolve this afterwards. So just like any parametric design, what we may want to go ahead and do is put some dimensions to the product so we can quickly and easily start to go ahead and set some real reference dimensions for our design. So we may want 23 on this side, we may want to go ahead and put some angle dimensions in, and really quickly within Fusion we can go ahead and start to generate all the information required when we go to production right at a concept phase just here. So we've got a few more dimensions to put in just here. So we may want a height dimension or even a width dimension between these two lines just here. Maybe a height dimension for the overall of 75 mil, and then maybe a overall from the origin as well. So really quickly, as you can see, we've got all of those dimensions in place ready to go. Now we'll take that design that we've just created, or the sketch that we've created, and we can jump into a revolve really quickly. From just a 2D product, we can turn the product directly into 3D. Now, it's great, but it's looking a little bit blocky. So let's go ahead and put some more curves to the design itself. And Fusion's got a real powerful modeling engine, so really quickly and easy we can start to generate some real nice shapes and curves for the design by just using our fillet tool. We need to put a shaft through the center of the design, so we need to go ahead and create a little hole that we need for our design itself. So we'll make it a 20 mil circle on the center of our design. We may want another one of those circles just below, just so that we can fit a secondary shaft in place, just an idler. And then we'll go ahead and put a dimension between the two of, let's say, 10 mil. We'll also go ahead and line this second circle up by using some constraints to this first one. And then from there we can pick the areas that we want to go ahead and create a hole from, and we'll just go ahead and drag that back, and again very visually we can see exactly what we're doing within Fusion itself. So great, we've created one end of this chest itself. So what we want to go ahead and do is mirror this to the other side so we can quickly create a volume that we want to go ahead and put the more ergonomic shape within. So great, we've created a parametric design within Fusion. We could go ahead and go into our drawing environment just here, but we need that ergonomic shape in the middle first. So we're going to jump into Sculpt, and we're going to go ahead and use a primitive shape. Now Sculpt is like using plasticine. We can quickly and easily start off with a primitive shape, put any symmetry and bits and pieces in it that we need to, and we use push and pull technology. Now this technology is called T-splines. So from here we can quickly start to generate some real ergonomic, real nice detailed shapes for our design. We may want to go ahead and create some hard edges just here so that we can line all of this up to the parametric shape that we've already generated. So we're going to use a tool called crease just to crease those edges. And what we'll also go ahead and do here is just select those faces and flatten them off, kind of creating almost like a drum for our design. Specifying a couple of edges, we can quickly jump into our edit form tool and allow us to quickly push and pull that design as we need to. We can scale edges, we can drag, and we can move as we need to. So it is just like when we used to play with Play-Doh or plasticine as kids. So great, we've been able to go ahead and line everything up at the moment. But what we want to go ahead and do is just drag this front section out. It's as easy as a couple of clicks. Really quickly and easily pick the point, choose how you want to drag it, and you can quickly go ahead and drag that design. So generating that initial wow model and the initial ergonomic shape is quite quick and easy to do within Fusion itself. Already with a few clicks, we've generated Princess Leia's head just here. So really quickly and easy, we've been able to go ahead and look at generating the part using parametrics, the two side pieces, and also using T-spline technology to generate that middle ergonomic shape. We'll give it a save, and it also creates versions for us. So let's just jump back into the PowerPoint. We've looked at that 3D design development, generating the actual parametric shapes that we need initially. We've gone into the complex surface design tool slightly so that we can start to look at some of those ergonomic shapes, and it's all within that one integrated environment. So let's go ahead and take a look at some of the benefits. We can speed up that design development. Like I mentioned, it's in an integrated environment, so we can quickly and easily go ahead and iterate the design between the two, and we have that ergonomic and mechanical design in one. No need to go ahead and turn add-ins on or off. We've all got that all in that one environment. That's our design phase done. Let's move over into our communication. Now, communication is key when generating designs for our customers. So we're going to go ahead and look at some of the really powerful communication tools within Fusion 360. Now, we can collaborate with different teams on different time zones quite easily within Fusion. We have something called live review sessions, which we'll go through in a bit, and we'll also go ahead and look at some of the approvals and recommendations quite instantly that you can get. So let's jump back into Fusion. Let's go ahead and look at this communication tool. So down at the bottom of the Fusion window on the left hand side of the screen, you'll see a little comments tab. From here, we can start to generate comments for our design, giving any kind of comment that we need at any type of position that we need at this stage. So let's put in chest V1 done. What do you think? And we'll post this. Now, one of the key things for us within Fusion is we've got the ability to either open the design on a web or even on a tablet or a mobile phone. So we can quickly and easily go ahead and access that design anywhere we are in the world. This is just in a web browser. So as we can see from here, we've got that design open in a web browser. We can see the version, and we can also go ahead and share that design with anyone we need to. This can be public, or we can put a password to this to make sure that it's a little bit more secure. If we view that design, we have a lightweight browser viewer, so we don't have to install anything on our machine to do this. We can quickly and easily go ahead and start to interrogate that design, looking at section analysis, maybe also going ahead and doing a bit of measuring if we need to. But we can also go ahead and see the comments that have been made for our design. Now, I made that comment directly within Fusion. We can see that directly there, but this customer may want something a little bit more. So maybe we want to go ahead and put a handle in this bottom area. So we can pick on a point as to where that handle needs to be, and we can attach a comment to that. So it gives us the ability to quickly and easily start to communicate that design with a multitude of different teams. Popping back into a Fusion and giving it a quick refresh on the comments tab, we can see that comment appear. So really quickly and easily, we get the ability to have that co-collaboration with whoever we need to within the actual design environment. So we need a handle here. Okay, let's go ahead and start developing that design within Fusion a little bit further. So we're just going to jump back into the T-spline itself, or the ergonomic shape that we've created, and we need to go ahead and create almost like a boundary so that we can go ahead and drop that handle in, and we're not going ahead and affecting anything else on the design itself. So we'll insert a couple of edges just here, just so that we can create a small little boundary that we can go ahead and use. And with that, we also want to go ahead and just tweak this shape a little bit. Now, popping back into our edit form tool, we can quickly grab points or vertices within the actual T-spline itself and just drag them around, giving us some real free form fluid tools that we can quickly start to develop our designs with. And again, giving us the ability to generate the kind of data that we need for the customer. Now that's done, we can see that symmetry has allowed us to do that on both sides. Now what we want to go ahead and do is create that handle in this top section. We'll get rid of the symmetry initially so that we can then go ahead and bridge between. And we'll pick up on these four areas just here, or these four divisions that we want to go ahead and use. Just dragging this handle up, we can quickly generate that handle in a primitive. From here, we need a handle, so it needs to have a hole. So what we can go ahead and do is use some of the powerful T-spline tools within Fusion to go ahead and generate that. Bridge allows us to quickly and easily pop a hole through there, and we can then start to create the kind of handle shape that we're looking to use. Again, real fluid, really easy to do within Fusion. This is a lot more difficult to do with potentially other software on the market. Now, really quickly and easy, we'll just finish off this handle design. We'll just push and pull, create a nice handle that we need. We may want to go ahead and start moving this around a little bit, make it slightly shorter, give it the right angle that we need on the design, and really quickly and easy, that real complex geometry is done directly within Fusion. So now that that handle's added, and we've done that within a matter of minutes, popping back to the comment section, let's collaborate and let's communicate this design change to the customer. So we can say handle's done. What do you think? We can post this back to that customer and it will upload that design, and it will also upload that image that we've just generated there. So now that it's uploaded, let's pop back into the web browser. We'll give this a quick refresh. So we'll pop back to our standard demos itself. There we go. We can see the chest, and it's now got another version attached to it. And if we view the design, again, directly within the lightweight web browser, we can already see that that design has been updated. So instantly we can start to get some feedback and collaboration from our users or from the customer that we're going to go ahead and work with. So customer can go ahead and say, looks awesome. Can we potentially look at a 200 Newton load on the top face of this design? So it gives us the ability to, again, collaborate all the way through. So let's just finish off that note. And let's see if this product will withstand the test of time. So we'll reply to that comment that we've already created, and then we'll pop back into Fusion. And what we can see from Fusion is we see that reply directly under our comments tab. So instant collaboration for us just here within Fusion 360, giving us some really powerful collaboration tools that we can go ahead and use. So let's pop back into the PowerPoint. And what we can go ahead and do, like I said, we've collaborated with users. We can open up the design within a web browser or even a mobile phone. We can quickly and easily start to create comments within Fusion, and we can develop our design quite quickly, giving us the ability to have that back and forth with anyone, speeding up that communication and getting that approval almost first time, giving us that collaboration across time zones and across sites, and reducing that time and cost having to wait for someone to go ahead and try and approve the design. So that's the communication side of things done. Now the customer wanted to see what would happen if we had a 200 Newton load on the design. So let's pop into our testing phase. So we're going to go ahead and look at virtual testing this design with a 200 Newton load at the top face of the product. We've got some high-end testing tools within Fusion 360 that we're going to go ahead and take a look at, and we can check to see if this is built to last. So let's come back into Fusion, and again, we don't have to go ahead and add in a product or anything like that. We can jump into the simulation side of things. But first, we're just going to join everything together. So we're going to make Princess Leia's head 1, and then from there, we're going to go back into our workspaces, and we'll pop into our simulation tools. Now we have a multitude of really high-end simulation tools that we can use for Fusion 360. Starting off with static stresses, we can do structural buckling, modal frequencies, thermal stresses, event simulations, nonlinear, and shape optimization. Shape optimization being the start of the generative design phase. So from here, once we've specified a static study, we can then go ahead and start specifying the study materials, and we have a material library that you can pick from or you can add to. Specify the constraints. This is where the actual part's going to be held in a real life scenario. So it's going to be on these two areas just there where the shaft would go through the middle. And then finally go ahead and apply the load to our design. So from here we can start to go ahead and specify the overall load targets. So where that load's going to be applied to our design. We can go ahead and reduce the size of that target if we needed to. And we can also go ahead and give that load a magnitude. So for this design, we're going to go ahead and say that's 200 newtons. So really quickly and easy, the setup goes from left to right. We can check to see degrees of freedom. And then finally, we can make sure that the design is all verified and we've got everything in it. And we can go to solve. Now we have two options for solving. We can do cloud and local. Cloud gives us the ability, if we don't have the hardware at hand, to go ahead and push all the processing up to cloud. We also have local. So if you did have the hardware, you can quickly and easily go ahead and run that simulation like I'm doing here locally on your machine. So a real flexible approach to not just simulation, but we'll also see that a little bit later with the rendering as well. Once the simulation is done, we can go ahead and start viewing the results. In a real quick and easy fashion within Fusion 360, we can start to look at displacements, stresses, we can start to look at factor of safeties and strains, giving us a real good indication of what that product's going to do whenever it goes ahead and has that 200 Newton load applied to the top of the design. We can animate and record, giving us the ability to again communicate that design and get the approval first time. And finally, we can also start to generate reporting functions from this as well. So let's go ahead and pop back to our comments phase. Now, the customer wanted a 200 Newton load on the top face. We've done the simulation. Let's go ahead and allow them to look at the results. So we can say that the stress test is done. We can check the results. And we can go ahead and see what the customer thinks. So again, if we post that, again, posted it just there. Let's pop back into our web browser. And from our web browser, let's go ahead and give this again another quick refresh. So from here, we can see that it's already saved a version, another version itself. And if we did want to go ahead and change that design from, let's say, a first concept, we can always promote a previous version. And we can see that comment on the right hand side of the screen. So the stress test is done, and we can also see that all those comments have been version captured. So you can capture an audit trail for your design. Let's pop into the View tab, and from here we can start to see the simulation results directly live within our web browser. Again, nothing needs to be installed, so from here we can quickly and easily go ahead and interrogate the stress results that have been created. No need to send emails or anything like that anymore. We can quickly and easily do that directly within a web browser, giving us instant feedback for stresses and displacements, making sure that the design is correct. So from here, the customer's happy. So he can say, great, looks good. Can we now render the product? So we're going to jump back into the rendering side of things in a moment, but that is our testing side of things done. A real quick and easy way to go ahead and generate that test and create the kind of data that we need. And as we can see in Fusion, we can see what the customer requires. So again, we've got some virtual testing or some really high-end virtual testing tools within Fusion 360. The ability to take a design from art to part. We can reduce those prototypes, get that right design first time round instead of iterating on prototypes and potentially reducing that time to market for the product. So that's our testing tools. Customer wants to go ahead and see a visual of the actual product itself. So let's go ahead and pop into our visualization tools within Fusion 360. Now again, we have some really high-end rendering tools within Fusion 360. Using ray tracing technology, we can create some really nice images. These can be cloud or local render, and it's a real easy and quick setup. Just like the simulation, we'll start from left to right, giving us the ability to create some real nice renders directly within Fusion 360. Popping back into Fusion, the customer wants to see that render. So first thing that we want to go ahead and do initially just here is drop that chest into FK9. So from here we can go ahead and just insert our chest design that we've just created, and we can quickly and easily go ahead and rotate and move that into position as we need. Now for this design I could just leave it where it is, but what we're going to go ahead and do is just drag this out a little bit, and from here I'm going to show you some of the tools that we can use to then start to joint things together. Now our tools to put things together in an assembly are called joints, and they're really useful and really powerful. So what we can do here is activating the joint tool. We can select that we want the center of that shaft or the center of that hole to sit on the center of our shoulder just here, and Fusion will go ahead and joint those two together. Now one of the key things that Fusion does do here is it allows us to animate the kind of movement that we would get for the product itself. So we can release the area that we want to go ahead and use. So if this was sliding along that shaft, we can go ahead and just release the sliding element of that product. And really quickly and easily, the chest's in place. It looks like it fits quite well. We may want to go ahead and just combine everything together just here so that it is one complete body as well. Now with that, let's go ahead and bring back the chest cover that we saw that I hid earlier right at the start of the demo. So quite quickly we can just hide and show that. And let's now jump into our rendering workspace. So Mac's done. Let's pop into render and let's go ahead and start looking at how we render this product as well. So our rendering workspace, again, the UI is completely the same as it was before, just some different tools along the top, and we can quickly start to set the kind of camera angles and the position of the design. We have a load of different appearances that you can add to your designs, and we can also download extra ones directly into the library itself, as you can see. Now, if I want to use this metal flake appearance, all we need to go ahead and do at this stage is drag and drop. There's no need for us to go ahead and go through any complex processes. It's just a simple drag and drop to add that to our design, and we can add that metal flake. Once we're done with all of our appearances, we can start to specify the environment. So we can specify the type of ground that we're going to be using, the type of environment we want to go ahead and put our FK9 into. So from here, we can quickly and easily go ahead and have all of that information set. I'm going to just activate an in-canvas render just here. So this is going to turn my screen into the rendering environment. So from here, we can start to see all of the LEDs and bits and pieces appearing. Now we're using ray tracing technology, so we can quickly and easily start to set a threshold. Ray tracing is just going to refine the image until it reaches a threshold, and it goes ahead and gives us that really nice final image that we can use. And again, just like with simulation, we have the ability for cloud and local render. So we're taking away that hardware requirement for you to have. If you need to do rendering, you don't need a heavy machine to do that. You can pop it onto the cloud for Fusion 360. And you can also, at this stage, create turntable renders. So if you just wanted to show a real nice render of our FK9 turning around, we can quickly and easily do that within Fusion 360's rendering engine. So let's pop back to the PowerPoint quickly. So again, we have those high-end rendering tools. We can quickly apply those appearances and the environments, set our depth of field, all of our reflections and bits and pieces, and we can send the design to either cloud or local rendering. Again, giving us the ability to take away that hardware requirement from you. So we can create those stunning visuals with very little effort within Fusion, reducing those hardware costs that are very dear on traditional packages, and we can quickly get those approvals first time from the customer. Now, great, we've been able to go ahead and take the design through from a design, communication, test, and visual, but we need to make it. So what we're going to go ahead and look at here are three different elements. So we'll look at additive and subtractive manufacture. In Fusion, we can do anything from 2.5 to 5 axis machining included, and we can look at all those detail manufacturing options that we'd get as well. But we'll also look at a third different modeling environment called direct editing. So the first things first, let's go ahead and look at some 3D printing. So we've got our design. This is just the hip section of our Fusion Canine. And what we want to go ahead and do is send this for 3D print. We can go ahead and send it to a printing bureau, or what we can do directly within Fusion is actually select the design, make sure that the mesh is okay, and push this out to an STL or an OBJ. From here, we can also go ahead and launch something called Print Studio, or a third-party program that we can then go ahead and use to do all of the slicing for us. So Print Studio will allow us to quickly and easily go ahead and initially set a printer that we want to go ahead and use. So let's say we want to go for a MakerBot replica. From here, we can scale that design to fit, so we can quickly and easily have the type of design that we need directly within the bed of the printer, making sure that it does fit. And we can also go ahead and move that around, giving us the ability to go ahead and make sure that we optimize the rotation for specifying our supports. Print Studio will allow us to quickly and easily start to add the support structures into the design itself, giving us again a quick environment that we can use just there. And then once we've hit the preview tab, this is then going to go ahead and generate all of our tool paths for us. So it gives us the ability to quickly and easily go ahead and have a real nice toolpath that we can create, and showing us all of those slices as we go through the actual process itself. So again, giving us an overall estimated time, and at this stage we can also export directly to a printer file or directly to that MakerBot. Popping back into Fusion, like I mentioned, we have integrated CAM tools. So initially we can go ahead and choose whether we want milling, mill turn, or even water jet cutting. We can go ahead and specify the stock offsets that we need, and we can also specify where our origin is going to lie on the actual stock that we're going to be using. Once all of our stock set and our setup is done for our design, we can start going into either 2D or 3D milling options. 2D options, we have to pick our individual contours. 3D, we can just go at it and they're automated strategies at this stage. We can specify our tools that we want to use, and all of our tool libraries are customized to suit the tool cribs that you guys have. And from here, all of our feeds and speeds are set. We can specify what boundary we want to go ahead and machine. So if I want to go ahead and machine that boundary, we can. We can go ahead and specify the overall height. So if our bottom height is going to be the base of that top section of this flange, we can go ahead and set all of that quite quickly within the design, and again, very visually. And then from here, we can start to specify bits and pieces such as stock to leaves and also our ramping conditions for our mills. From here, this is then going to go ahead and start generating all of the automated toolpaths for us. So using that adaptive clearing strategy, we can quickly and easily go ahead and start developing the CAM toolpaths that we need for our design. Just simulate this design and we can see that toolpath completely created as a real quick roughing strategy that we can go ahead and use. We can take this design further and start to manipulate that as we need to. Fantastic. We can see a real nice toolpath starting to be created already. Now let's go ahead and pop over. We can post this out now, and we have the ability to have our own post, so we can have certain posts set in our cloud libraries, but we also ship Fusion 360 with a whole host of generic posts that you can then go ahead and grab. If you need to modify any of these, you can directly within Fusion as well. Now, once the design's done, great, but what about if we need to go ahead and change this? Now, if we pop back to the modeling environment, what we can go ahead and do is use something called direct editing. This gives us the ability to quickly and easily use push-pull techniques to generate the kind of shapes or changes that we need for our design. So we can just grab faces and we can go ahead and make some dimensional changes if we needed to. It's quite simple to do. But what about if we wanted to go ahead and change maybe the diameter of that hole just there? We can pick up on the hole and we can quickly and easily start to make some diameter changes to that hole as well, specifying whatever size that we need, and you can start to see that visually as well by just grabbing that arrow. Now, what about we've got this design in, but we may want to go ahead and change one of those slots out, maybe move it around a little so it's not quite symmetrical all the way through. We can jump into our direct modeling engine to do this. Now, Fusion's unique in this environment because it allows you to do both parametric modeling as well as direct editing, and the power of each is incredible. We specify what we want to go ahead and move. We specify a pivot point that we were going to go ahead and use, and really quickly and easily we can start to grab and just drag areas of the design to go ahead and start making changes. It's a real powerful methodology to use, and you can see that everything updates accordingly. Now, what about if we want to go ahead and move this hole slightly down and maybe have two holes instead of just that one cutout or one slot? We can just, again, dynamically grab and drag. There's no need for us to go ahead and delete geometry, redo geometry. Really quickly and easy, we can go ahead and make sure that everything updates accordingly as well. Now that's all great, but what about if we want to make a bit more of a major change? This top section maybe needs to go ahead and be rotated by about 6 degrees. So what we want to go ahead and do here is potentially pick up on all of these faces that you can see on the screen that I'm picking. And from here we want to go ahead and maybe make some small, like I said, make some changes to that design itself. Okay, let's just pick this bottom edge as well. Great. Now, we've picked all of that area just there. The power of direct modeling allows us to quickly and easily go ahead and just grab and drag. The chamfer below, as you can see, makes those updates with those changes, giving us the ability to quickly and easily go ahead and make any changes that we necessarily need for our design directly within our design. Now, that's great. I've put a CAM toolpath to this. Right click, regenerate the toolpath. All the stock has updated with all the overall sizes that we need, and so has our toolpath. So Fusion 360 has an extremely powerful integrated environment to do this, giving us the ability to quickly flow through, make any changes that we need to, and have all of that information directly there. So what we actually have is low-cost, high-quality manufacturing directly within Fusion 360, reducing the effort and time and giving us a faster time to market. And that's our create phase. So what we've looked at here is the design element, popping that design to communication, going from communication into testing, testing to visualize, visualize to creation, giving us a real quick environment that we can use and one single integrated platform. So we've touched on a few of these areas just here: parametric modeling, some part libraries and contents, some machining options, and that all sits at the center of our product innovation platform, giving us a complete design, make, and use integrated solution.